All right, so a ballistic trajectory is always going to be, we can always treat the y position and the x position separately. So people who have done this in physics are aware of this, but if you haven't, that's okay. It was just to learn what you need to know now. So the height of the object we can just consider separately. And there's an equation, v0, which is the initial upward velocity, t, minus 4.9 t squared. All right, this gives the altitude of, it's just the altitude, the y of t, of an object that's traveling under free fall. All right, so we just threw it, but we threw it upward, and that's the initial velocity. So I threw the ball, maybe it's a ball that I'm throwing upward, and the upward velocity is what determines everything about the trajectory. All right, we call that v0, the initial velocity, the initial upward velocity. And so if we consider, v0, I mean, v0 could be negative. We could throw something down, and then it would actually follow the same y of t. Typically, when somebody's doing this, we threw it up. But you could be, for example, standing on the top of a cliff, all right, and throw something down so that the v0 is negative. Right, you could do that. And then the altitude would be given by the same equation as if you throw something up and it follows this nice parabolic curve. All right, so we can ask things now, given this, like let's say I throw a ball upward with an initial velocity of 48 meters per second. All right, and then I can easily answer using calculus questions like, what is the maximum height that the ball achieves? Right? So I throw it upward with my upward velocity of 48 meters per second. So, like you might actually have thrown it like partially upward and partially to the right. And then we can treat those two velocity components, as they're called, differently. So this is our V0. And so in physics, they'll call this V0y and V0x. Because we're also, you might have thrown it like in this direction, so it goes both up and to the side. But we can consider both of those types of motions separately. So the V0 we're talking about is just the upward component of that direction. So what is the max height that this thing reaches? This is the same question, or right when does it reverse direction? So the object reaches its maximum height at the time when it stops going up and starts going down. So this is the same question as, when does the vertical motion change direction? All right, so that question is what we considered up here. So an object changes direction when S prime changes sign, and that happens when the S prime is 0. All right, so so if this is our y of t, what we're going to do is say, when does y prime of t equals 0? And since in ballistic trajectory, the equation is always quadratic, that means that the derivative is always going to be linear. And that means that, so a linear function is always odd multiplicity because the exponent is 1. All right, so y prime so let's actually, instead of starting here, let's write the equation. So y of t equals, since we're saying the v0 is 48t minus 4.9 t squared. So then y prime of t is going to be 48 minus 9.8 t. Right, that's just using power rule. And then I set that equal to 0. So we set y prime equal to 0. That's going to be always our starting point for finding reversal of direction. So then you can get 9.8 t equals 48. And so t equals 4. So if we round it to 3 decimal places, it turns out to be 4.900 seconds. Now, at t equals 4.900 seconds, what we know is that the velocity is instantaneously 0. The vertical velocity is instantaneously 0. Now, when the vertical velocity is instantaneously 0, that does not automatically mean that the object changes direction. we need for s prime to change sign. Since s prime is a linear function, when the linear function equals 0, it does change sign. So essentially, it's the multiplicity of a linear function is always 1. So that means that's an odd intercept of this graph, the graph of y prime of t. If you want, you could think of a graph of y prime of t. It's y-intercept 48, slope negative 9.8. So at this point, 4.9, v of t, y prime of t, which is velocity of t, changes from positive to negative. Therefore, the object changes direction. But for free fall, a quadratic function of position has a linear velocity function, you don't have to think about that. So wherever the velocity is 0, in a trajectory, there's only one place the velocity can be 0. That's at the top of the trajectory. So that is the maximum height. Now, this gives you the time when the maximum height occurs. But if the question says, what is the maximum height, then I need to plug that time into my height equation. So, my height equation is here. So y of 4.9 equals 48 times, let's put this on the next page. So I have, because I'm running out of room there, t equals 4.9, that's my maximum height. So y of 4.9 equals 48 times 4.9 minus 4.9 times 4.9 squared. So we'll just throw that into our happy calculator that we put away because we didn't think we had to do this part, but we do. Into the bag of tricks and calculator. And so, all right, so we're going to do 48 times 4.9, and then just to simplify what we're putting in there, we'll just go minus 4.9 to the third power. It's just a coincidence that the 4.9 is matched. Anyway, you've got 117.551 equals 117.551. So the maximum height is 117.551. Now I could look for units in this, right? So but I didn't put any. I did put meters per second here, right? This is initial velocity of meters per second. This equation actually only operates when y is in meters and v is in seconds, because of the 4.9, which is 1/2 the acceleration of gravity. If we were doing feet in seconds, this number would be 16. Yeah, I could have just put the units in instead of saying all that. That's what we do. Meters. So I've written my answer as a complete sentence. And so look at some of the things that we did and some of the considerations you have to take into account. I'm looking at a V0 of 48 meters per second. The AP exam is not going to expect you to know this equation. What they will do instead is they will give you a position equation. And then they will say something like, this equation describes the height of an object. What is the maximum height of the object? All right. And then you will do your derivative. And what you found here, though, is not the maximum height. This is what I want to emphasize. This is the time when the maximum height occurs. But this question says, what is the maximum height? Therefore, we have to take another step and take that time when the maximum height occurs, put it into the height equation that tells us the altitude or height that we're at, and that will allow us to calculate the height and use the correct units in a complete sentence.